Good morning, and today we're going to get into some Linux forensics. This was a recent CTF that I did, and I've just finished the write-up for it. So I'm going to take you through the solution for the actual CTF, but if you jump on my GitHub, there's a whole bunch of information here on how to set up Linux profiles to do Linux forensics using volatility, which we need for a small portion of the CTF, and it does help to confirm some of the flags that we need to get. To start off with, I want to have a big shout out to Angry Bender, who's one of my work colleagues and friends who has helped me so much just understand Linux kernels. I would have been completely lost. So on my page, once again, you can go to his content here. I hope you enjoy his stuff, and he's always open for any questions that you may have. So we'll skip over all this stuff. This is all the how to get the information needed to create the Linux profile to then use with volatility. And we're going to go straight down here to the scenario section. So you're working as a incident analyst, and the SOC has left a USB with a sticky note on your desk, and it's Friday afternoon. They're like, go check this out. So you can download all the content here. This is the zip file. It's hosted on my Google Drive at the moment. I'm going to try and figure out somewhere else to host that eventually, but it's fine. It's only 93 megs, I think. And then this is a task we're asked to follow up on. So we need to download it, confirm the MD5 so it's not corrupt, and then we're going to go through and do some of these questions. So we'll come back to this page when we're going through it. I advise you give this a go yourself, just using the questions, and then watch the video. So let's get into it. I've already downloaded the file. So what we get in the zip is a system map file, which is explained in that setting up the profile thing if you want to go back and read that. And we also get the vmem file, which is just a memory image file taken from a suspended or closed down, or a suspended virtual machine. I'm pretty sure it still exists if you close down the virtual machine, but you can check. It'll just be in the virtual machine's directory where you've saved it. So we need to get the MD5 sum of the virtual file. So let's just do that quickly. There's your MD5 sum right there. So if you get the same, then you're all good. All right, let's check out the next question. So what does the CVE use for initial access onto the system? Format CVE year number. So let's look back at this statement here. You've received a report that an IP owned by your company, so ends in .28, has been communicating with the malicious IP .29. So these are both internal addresses, although for this scenario, we're just assuming this is kind of like an outside, or it's being used as a pivot box into your network, and you know that this is malicious somehow. So let's, I guess, search for this. So Linux memory files are very rich in strings because most of Linux is strings based. So we can use this, or we can use volatility to get this kind of information out. But first up, we're just going to try and grab information out. I can't type this morning. All right, so strings. So I'll just show you what this does. So strings is a tool in Linux that just tries to get out human readable text out of whatever file you feed it. So in memory, there's heaps, as you can see here. What we're going to do is use that ability and just grep for a particular string. So in this case, we want to grep for the IP address. And 129, yes. I always just like to use single quotation just so it's going to grep for an actual string, because grep can work, and you can also use egrep and do regex. So sometimes we need to escape certain characters, which I'll show you later on in another question. All right, so it looks like this malicious IP is connected to a fair bit within Linux. Straight up here, so Metasploitable is a machine created to exploit, pretty much to practice exploits. So you can go to Google and you can download this box yourself and run it up within your VMware or VirtualBox or something. Yeah, So you can see here, intentionally vulnerable Linux machine. So you can use it for testing, to practice pen testing, and it's one of the recommended things before you start OSCP. So straight away we know that this is kind of the CTF part of this challenge, is they've just run up Metasploitable and they're asking you questions based off that. This here looks dodgy, and so having attack C and the fact that the malicious IP is within this command, and it looks like twiki could be something, and it's sitting in the, so var www is the root web directory for most Linux systems. That could be something. It looks like it's also linked to twiki users, could be a thing. Going up, we're seeing a lot of these commands being run. Let's see what else. Some FTP. This could just be enumeration as well. Doesn't mean that it's necessarily there. Cool. Okay, so we've got a few things to look up. What I might want to do next is check the network connections that are on the memory image. So we can use this with volatility, and if you'd gone through the stuff, we need our profile first. So I'd already gone through all that. This is the profile that I'm using. So, and let's just clear the screen again. All right, so my beginner analyst playbook also shows you how to use volatility for forensics as well, if you want to go check that out. It just gives you some basic commands. So profile, put that in there. And now we want to check the network connections. So Netstat is a plugin that volatility uses. And whenever you're using it with Linux stuff, you just need to put Linux underscore before the commands. Otherwise, if you're using Windows memory images, you could just type Netstat. Cool. So let's also, just to make this clearer, let's do this, but we're only interested in the malicious IP. So let's just grep for that. Cool. So not too much. So this is closed. We're not that interested in that. Looks like we've got, this looks dodgy, like random string connected to 4433 port. You can do a quick search on that. So TCP port 4433. Let's just go to this first link. Oh, look, backdoor. So, yeah, it's not looking great. It hasn't come up and just told me that. So sometimes uses a standard HTTPS SSL web traffic port to 443. We know from Active Tradecraft that they generally like pushing things over port 80, 443, or any kind of the alternative ports if they're doing something malicious. The fact that it's a random string running on that port as the binary looks dodgy. There's also a whole bunch of telnet established to this port, which is also dodgy. Okay, so now let's go and look at, like I'm now interested in this. Let's look at the PS list and see what that's connected to. So PS list, this is the process tree for the operating system. So this will, if we go back up at the top, so process ID is PID and parent process ID. So when programs normally run, a program can spawn another process, or a process can spawn another process, and that's the link here. So down here we have this dodgy string, and its process ID is 8661 and then it's connected to 8623. So if we look here, this is 8623 and it's shell. So this is pretty much, SH is effectively command.exe for Linux. It is also linked to 8622, which is another shell, which is dodgy. So the command prompt is spawning a command prompt and then is spawning a dodgy process. And looking at the times of when all this has started, it was all on the same day. So it's not a long CTF, but we can see that it's spawning out some dodgy stuff. So cool. So from there, we kind of know that what we saw before, I'll take you back to, this one. So take you back to here. So we know that shell has spawned something dodgy, right? And what we saw here was we saw this, which sure, we can't see all this command because there's the ... here. But we know it's kind of dodgy, and there's the twiki, and we went up here and we're like, okay, this is also dodgy. So now let's do some research. What we're going to do is just Google, let's go twiki users, and then it had the taxi and exploit. And first link here, so MSF is Metasploit. It looks like there's an exploit for this. So let's just go into here. So .rb is a Ruby script, I believe. And cool. And this is our CVE. So when I did this CTF, this question probably took me the longest because there's so many vulnerabilities. That dodgy string is usually related to Metasploit. But yeah, the twiki is a built-in exploit within Metasploit, and this was the answer. So it would have been CVE TAC 2005 TAC 2877. And they just ran that and exploited the box. Cool. So we've got our first answer. Let's go back. So done question 1, question 2. What is the MD5 of the ELF implant in the memory? So judging off this, I already knew that random string looked really dodgy. So let's go back to that. So this GHPGF looks dodgy. Now we know that it's the Metasploit module that's running this. Let's pull this out and get the MD5 and try that. So we can do that. And this is the one part. So I guess the netstat and the PS list, you didn't really need to get that CVE. Where you need volatility for this whole CTF is this one question. So I believe it's proc dump tecp, and then we need to pass it so tecp is the process ID, so 8661. We also need to give it a directory to dump it into. So tec capital D, and then the working directory that I'm in, I can just dump it into that. So I'm just going to put a full stop. Cool. So if I now look at my directory, I have that process that it's pulled out of memory and dumped it into my working directory. I can then do an MD5 sum on that. And this is the MD5. So the implant was what we thought was dodgy by going through that process and seeing that it was spawning from the shell, because if we also go back to the netstat, so what an implant does is it sits on the system and then connects back to the malicious IP. So in this case, the implant was this, connecting back on 4433. So it's effectively I guess a reverse shell. And we've just dumped it out and got the MD5. So it sits here. So that answers that question. Cool. So what tool is used to create the implant and ELF binary? Now, while this wasn't the hardest question in the CTF, it definitely was the one that probably tripped everyone up the most, and this was like the last question that everyone answered, because I guess just the CTF-ism of this process and how it works. They were looking for a particular answer, and we were like uploading this binary to VirusTotal and just guessing like a whole bunch of things, and we just weren't getting it. What you needed to understand is what I think it's what was I looking up for? I think it was what implants does Metasploit use? Yeah. This is kind of like when I was doing the CTF, I guessed it and got it. So Meterpreter is what the Metasploit framework uses to create, I guess, payloads that can become implants. So what the CTF was looking for was this word here, Meterpreter. I guess like, a bit of a CTF-ism. It wasn't a great question, but that's why I've changed it here. So I've said, the question was slightly different, but I've said, what tool do you use to create an NS Meterpreter? Cool. What is the full path, including the file name of the web shell? So this one, you kind of like, it hasn't really been related to anything else. So what I ended up searching for was this. What do web shells look like in logs? And then I went to this one first. So what I've seen a lot of web shells is China Chopper, and they kind of have this format, but we don't, because we've got a memory image, we don't really have logs that we can just parse through and look for these kind of strings. So what we have seen in the memory image, if we scroll back up, is we see this kind of format. So we know that it's pulling stuff. There's probably some, even like here, so options. So this is the request string to the web page that it's trying to look like. So I guess what I'm trying to look for in web shells is something that looks like that can tell me that a web shell may be on the system. And this is great here. So I came to this Medium article, and it gives you like a rundown of Web Shell 101. So it shows you like how the PHP looks like. And so this is the keyword that would be the web shell, like the attacker would call to activate the web shell once they've loaded onto the system. This is a good example URI. So it's stored in images and it's a.php. So if we knew what the name was, we can grep through the memory image for, say, a.php, but we still need to find what that command is. PHP is a very common web shell, so we could just search for PHP, but I was looking for something a bit more solid than that. But yeah, then I kind of came down here and I was like, oh, okay, so maybe I can just search for like the get / because, and see what logs are pulled out of there. So that's what we're going to do. So we're going to run strings again on the memory image. And then we're going to grep for get. Grep, as another thing, is also case sensitive. And the reason why I put this / is because the / is an escape character. So we're just going to put that / there so it knows I actually want to look for that get string. And this is good. So it shows us the twiki exploit that was used. We also see this here. So the get / command.php equals command who am I. So who am I is a command that will tell you what privilege you are. And if you've done pen testing before, the first thing you do when you get an initial foothold on the box is you're like, who am I? Because you want to know what privs you have, what user you are, what you may have access to, and where you need to go from there. So straight away, this jumped out. This was dodgy. I guess there's nothing immediately jumping out. So from here, let's now look for command.php within the memory image. Cool. So less stuff to look through now. So dodgy IP, get command.php, who am I? So you can probably say straight away that the attacker is using a web shell that's command.php, and we can actually look at this. So command.php, and I think it's just web shell. You can literally pull this off GitHub, and this is the web shell that you can put onto a system and use. So what it's doing is it's running system, and if this is the same web shell that's put on this Linux machine, what system does is it runs the command and immediately outputs it, presumably as text, to the screen. It's a pretty basic web shell. If the user has a reverse shell, they can just call this URI and immediately it's spat back out to them. Yeah, cool. So yeah, we're seeing a lot of command.php. Command.php is within the PHP, I guess, framework. If you're running PHP in safe mode, command.php is disabled. So what we're looking for, this is potential vulnerability itself, but what we're looking for is something that's not in its normal directory, and that's here. So var www command.php. This is dodgy. Like, this PHP script should not be sitting in the web root of the box. Just not good practice, seems dodgy, and I believe that's, yeah. What was the full path including the file name? So this was the answer for this question in the CTF. Finally, what command was executed via the web shell? We've already seen that, so we found that before. That was the who am I. We saw the attacker running that. They wanted to know what privs they had. And that's it. So hopefully that was helpful if you're getting stuck on some of these questions. Some of them were kind of CTF-y in nature. But what I got most out of this was the setting up the Linux profile and learning a whole bunch from my mate Angry Bender, and just also all the other guys that were there. So I hope you've enjoyed this. I hope you've learned something, and I'll see you next time.